Now that we have the scientific, engineering, and aviation backgrounds, as well as some flight experience, let's get into airplane design. The engineering design process consists of 3 steps before production: research, planning, and prototype. Research includes studying the underlying engineering, math, and science principles. I've been doing research with every Fly to Learn lesson you've completed. Research can also include what others are designing and building, and what the public wants. Keep in consideration key engineering concerns: cost, money, and especially time. Planning consists of 5 steps. The first is identifying opportunity. A need or problem should always be considered an opportunity. The second is brainstorming, considering all ideas to come up with solutions. Then you must select one idea. The fourth step is to mathematically model that idea, to do calculations before construction because you work smarter and faster with your brain than with your hands. The last step is called proof of concept. You build a model to test your idea. A proof of concept is usually narrow in focus. For example, if you are designing a better airfoil, you would build a small section of the wing, not the entire wing, and certainly not the whole airplane. The prototype phase has just a few steps, but these may be repeated many times. The goal should be for your model to improve over the iterations. Then you're in the production phase. Once you are happy with your prototype, you have reached this phase, and the airplane is ready to be built. We will now run this process in PlaneMaker. The specifications for the airplane we are designing are as follows: a 4-passenger airplane, including the pilot. Each passenger can bring 20 pounds of luggage. It will travel at 150 knot cruise speed with a range of 550 nautical miles. This information would have been gathered and decided on during the research and planning phases. Now you will mathematically model the plane design, focusing on weight, wings, power, and range. Turn to the Designing Your Airplane section of your student handbook and complete the calculations, moving step by step and using the specifications listed there that we discussed. Often, we don't meet all of our design goals with the first design. If we don't achieve the necessary range, we can increase the amount of fuel, but then we will need more horsepower, which results in greater fuel consumption. Or we could decrease our cruise speed specifications, which results in a lower thrust horsepower requirement. As you can see, the engineer has to make informed decisions regarding performance trade-offs. Often, we will repeat this design process several times to meet our goals. Now, we can move into the prototype phase using PlaneMaker. We will modify the RV-10 plane in PlaneMaker so you can quickly try out your designs safely and economically. You don't have to reinvent the whole vehicle. Start by gathering all your math modeling data into the PlaneMaker chart under Prototype in your student handbook. Then, open PlaneMaker in the RV-10 airplane. Select Standard, and then the appropriate menus to assign your values to the appropriate fields. Once you have completed your airplane, save it as your name prototype and go fly it. Be sure to include the appropriate payload weight in the weight and balance section of X-Plane. If the plane performs well, you are ready for production. If you want another challenge, consider designing a sport plane with the following requirements: 2 passengers including the pilot, 250 thrust horsepower, aspect ratio between 6 and 8.